All right, so we're back. I wanted to do a little bit more with equations of lines, at least introduce them a little bit further. In the last one, we discussed all about the idea of, and this is what we had last time, the equations of lines and how it's a constant rate of change on that line, and that's why slope is important. We know that there are a few different forms of equations of lines. There's the point slope form that's valuable when you have a point and a slope. There's a standard form, which is just a standard basic definition for all lines. Notice that in that the power of x is 1. We talked a little bit about that in our class, actually, about that versus quadratics and all those other things. And then there is the slope-intercept form, which is the most valuable in our opinion, or in my opinion. You'll see that a lot more and you'll use it a lot more. Something is linear if you can see that there's a relationship. So from 1 to 2 to 3, you see there's an increase of 1 and it's constant. There's a constant change in x. And if I go from 4 to 8 to 12, and one thing that I was trying to do in the last one was to get rid of that 5 right there because I just threw it in there at the end. That is indeed a 4. And so when you go from 4 to 8 and then 8 to 12, you see you're increasing by 4 because that's a constant change in y. We say that this thing is linear. Now, what I wanted to also do before I left was figure out exactly or show how I went from one of these forms to the other and then to the other. Just doing some quick calculations because you may have to do this. So if you're given point slope form, I want to put that in, let's just say, standard form. Happens once a time, sorry. Standard form. I know I want it to be ax plus by equal to c. So I want x and y on the same side. Right now I have x and y on different sides. Let me distribute this so I can get it out. So y plus 5, not touching that. Let me distribute. So I get negative 5x plus 10 just by distributing. Almost there. I need to get this x over here and this number over there. So let me add 5x to both sides. This is just like when we solve for a specific variable or literal equations. And so I have y plus 5x plus 5, and that's equal to, say, 10. All right, closer, closer. I have the y and the x. Let me rewrite this. Let me put the x first because it looks more like our x form here. So 5x plus y plus 5 is equal to 10. I just rewrote it so it can look similar to this. Doesn't matter. But I do need to get this 5 out of here. So let me subtract 5 from both sides. All right, so I'll have 5x plus y is equal to 5. So this is indeed standard form. All right, so boom, 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 boom. Now I can go even further and put this thing into slope-intercept form. All right, so that's just going to take a little bit more algebra, but it's not that bad. If I have this 5x plus y equals 5, remember slope-intercept form is y is equal to mx plus b. So I need y by itself and then x on the other side with a number in front of it. Oh, y is almost by itself. Let me get rid of this 5x by subtracting it from both sides. When that's gone, I'll see that y is equal to, and I'm going to write the x piece first, negative 5x plus 5. Now that is slope-intercept form. All right. So you can use this. We're actually going to use this to graph. We're going to use this to find different bits and pieces. But that's how I could go from one form of an equation, say point slope, to standard to slope-intercept. So I may ask you to do some of that just to make sure we're solid. All right. Excellent. I think that should be it for this one. We'll